Circle C has its center at C, -4, 4, and passes through points A, -4, 8, and B, 0, 4. Circle D has its center at D, 3, 3, and passes through points E, 3, 6, and F, 6, 3. Chelsea knows that all circles are similar, so circle C is similar to circle D. She wants to prove that a circle's arc length is directly proportional to its radius by proving that the definition of a radian is valid. The radian measure of a central angle is defined as the ratio of the arc length to the radius. Theta is equal to S divided by R. So S is representing the ratio of the arc length, so S is arc length and R is the radius. To prove this statement, she uses the central angles of circle C and circle D in degrees to find the arc lengths, and then she uses the ratio to compare the arc lengths to the radius of each circle. Read her proof carefully and then follow the instructions. Arc length of arc AB of circle C is blank. Radius of circle C is blank units. Arc length of arc EF of circle D is blank, and radius of circle D is blank units. Because the ratios of arc length to the radius for the similar arcs are both blank, which is the radian measure for the angle of blank degrees, Chelsea has shown that the relationship between radius and arc length is directly proportional. Okay, so match each numbered blank to the expression. Okay, well, if we're looking at this, we know that the arc length of arc AB is going to be, I'm curious if they want it in radians or in degrees. So one way that I would answer this is I would just look and I would notice, okay, well they have this formula of the degrees, which I recognize from the beginning is the arc length, when it's just in degrees, is the fraction of the circle multiplied in degrees multiplied by the circumference. So again, the circumference is 2 pi r. The fraction of the circle in degrees, well, we know that the central angle cuts off arc lengths of the same measure. So this would be 90 divided by 360. So our arc length is going to be 90 divided by 360 times the radius. So circle C, the radius is 1, 2, 3, 4. So this is going to be 4. So I'm going to be looking for 90 over 3/60 times 2 pi times 4, which equals 2 pi. So I would keep that in mind. The blank one is 2 pi. So for AB, and I'm just going to actually just write it right here, equals, that reduces down to 2 pi. So then the radius of circle C, again, we already found that out, was 4, because we counted it. Okay, so now arc length of arc EF, so now finding the arc length for EF, and that's going to equal, again, since it cuts off a 90-degree angle right here, that arc length, that arc measure in degrees is 90, and that portion of the degrees is 360. That's going to multiply by 2 pi times the radius, which is 1, 2, 3. So this is going to be 2 pi times 3, which equals something. I'm going to let them do the work on that one. So I'm going to look for blank 3, and I'm going to be looking for 90 divided by 360 times 2 pi times 3, which is 3 pi halves. So this was 3 pi halves. And now the radius, which was 3, so this is blank 4 is 3. Because the ratios of the arc length to the radius for similar arcs are both. Okay, so this is what it's wanting us to find, the radian measure. So it's the ratio of the arc length to the radius. So again, the arc length was 2 pi, so the ratio of arc length would be 2 pi 2 pi divided by the radius, which would be 4. So I'm going to just talk you through this. We're going to just treat pi like it's not there right now, and 2 divided by 4 is 1/2. So this actually equals 1 pi, or just pi halves, since the 1 is typically implied. So again, since I'm not leaving that pi out, I'm just manipulating with the numbers. So 2 divided by 4 is 1/2. And so that is what the ratio is for blank 5, is pi halves. And it says, which is the radian measure for an angle of 90 degrees, since that's what we have at 90 degrees. So those are the blanks.